Hello everyone. Today we're going to be doing an analysis over the smart meter communications using machine learning. In our agenda, we're going to have an introduction, the goals, a brief problem statement, some questions that need to be answered after the analysis, the methodology that we're going to use, and also the findings and the observations in the models, and finally the conclusions and recommendations to solve the problem. Many utility companies across the United States have started implementing advanced metering infrastructure, which is based on meters interconnected with the company's premises through a mesh network, speeding up the billing processes. Also provide their customers information about their services and consumption reports. These open new challenges in terms of cybersecurity, because once the information travels through a network is clear, this infrastructure is going to become a target. This also contributes to the smart city projects ongoing in the different cities in other countries as well. Our use case is a utility company with an advanced metering infrastructure project which will hold about 5 million electric smart meters and 300,000 water meters across the New York State. This connectivity between the smart meters and the company's premises goes through a mesh network owned by one of the most prominent contractors in the United States. As a proactive strategy, this company pings the meters on a daily basis to be aware of their status, so the devices can send updates about reads, events, etc. These transactions are called RCD, or Remote Connect and Disconnect. Many of these are failing for multiple reasons. One of them is the outages in the area, or simply the devices go offline. But there are one or more other invisible causes why these transactions are failing in the background. The goals that we are pursuing with this analysis are as follows. Investigate the root cause why many transactions are failing during the remote connect and disconnect process. To predict how successful will be the workflow to be validated by the Public Service Commission, which is no less than 95% successful transactions. Provide a conclusion and recommendations for enhancements on the workflow performance. This is a high-level explanation about how the RCD transactions work. The company has on-premise systems in place that will be communicating through the mesh network with the meters in the field. Every meter have to send an ODR. ODR is the on-demand read, which represents the last valid read the devices have registered over the time. So if without that operation, the RCD transaction cannot be validated as good or successful. That will represent a failure on the transaction. Otherwise, if the ODR makes it to the meter data systems, the transaction will be validated as successful, including part of the other operations internally in the meter data systems. Before going into the analysis, these are the questions that we should respond after we finish. Are the transactions failing because of network issues? Do the transactions workflow have a point of failure? If they do, which one would be that point of failure? What should be the maximum level of failure that will be tolerated? In our methodology, we're going to use the following: a data collection, the problem definition, training the models, the hypothesis, provide the evidence, and the metrics that we are going to study, like accuracy or score, recall score, precision or misclassification, mean absolute error. Our data collection, the questions we have is where is data comes from. This data comes from the communication between the meters and the company's premises. Um, this is being logged into a database. We just have collected part of it. What is going to be the target of this data set? Well, in this case, it's going to be the outcome. The outcome which let us know what transaction was successful and which one was not. Based on the target, we will be predicting on the first hand, which is the outcome, representing a binary value, which represents success and failure. We can say that this is a classification problem. If we need to go deeper for investigating the root cause of this failure, we might need to use the linear regression models for predicting numeric values on specific features. After our problem definition, we came up with this hypothesis. The remote connect and disconnect transactions can be only successful if the meter sends the on-demand read to the premises. According to our problem definition, we need to implement a multi-classification in order to select the most accurate model for the predictions that we are looking for. In the list we have the logistic regression, decision 3, linear discriminant, LDA. We have also quadratic discriminant analysis, QDA, stochastic gradient descent, support vector machines, nearest neighbors, and naive Bayes as well. So after we do a compilation of all those classifiers, we will determine which one will be the most accurate for us to make the analysis. Here we have the experiment. We're planning to use a multi-classification for getting the best classifier for this use case. As we listed previously, we have the logistic regression, the decision tree, linear discriminant, quadratic discriminant, stochastic, vector machines, the key nearest, the naive Bayes for conditional probabilities as well, and finally we have the experiment evaluation where we have all the numbers. Here we can see that the best classifier would be the decision tree. It has the best accuracy, precision, also the mean error. put it on the observation, like is the best classifier that we can use for this use case. We're going to proceed to create a new decision tree classifier for visualization purposes. As we see, we split the data again, train the model, print out some predictions. The accuracy we see is still good. I did put the testing on the data frame just for confirmation. And let's put this comment here so we can let everybody know that we can filter by failure as well. So finally we have the decision tree with the information related to the ODR. The ODR basically it says that the ODR is a mandatory feature in order to get a successful transaction. So we see even we have higher outcome on the ODR. We have the observation here at the end. After running the multiple classification models, we agree in this case that the decision tree will be the best fit for this use case, so we can support our hypothesis. Let's see why the decision tree is the most accurate. According to this decision tree, it seems like the RCD transactions are only successful when the value of the ODR time is less or equal to 0.05 on the first node. If it's higher value, will be success depending on the other operations, will be also success as long as they are greater than 0. ODR, as we mentioned at the beginning of the presentation, means on-demand read, which is every meter must send before disconnecting and after connecting to the network. This analysis suggests any transaction will fail without an on-demand read operation completed. This also suggests we need to predict the value of the feature to see what would be the reason why this operation is not getting completed in the middle of the transaction. According to our analysis, now we have the response to the questions that we asked previously, and we have confirmed that the transactions are not failing because of network issues. It does have a very important point of failure, which is the ODR time specifically, which is the time that this operation takes for getting an on-demand read at the beginning or at the end of the transaction. And according to our predictions, these analysis meet the expectations of the Public Service Commission as well. According with the findings, we can say the main reason why the RCD transactions are failing is because of on-demand reads operation time, representing the main point of failure of the RCD workflow. There is no evidence this issue is being caused by network issues or network latencies or any form of authentication. As a result of our analysis, we could recommend to this company to contact the vendor for re-evaluating or troubleshooting the workflow, coordinate with production support team in order to put in place monitoring tools to find out possible reasons why the failures are taking place, to coordinate working sessions with the vendor's team for any possible changes or corrections in the application.